In this section, we will be introduced to solving equations. The solution of an equation is the value or values of the variable that make the equation a true statement. The set of all solutions of the equation is called the solution set. We sometimes say the solution satisfies the equation. For example, determine whether x equals 3 is a solution to the equation x plus 9 equals to 12. So let's go over the definition again. The solution of an equation is a value or values of the variable that make the equation a true statement. So let's replace 3 as the value of x in the equation x plus 9 equals to 12. Remember, anytime you replace a numerical value in the variable, make sure you use parentheses. So we have 3 plus 9 equals to 12. This gives us 12 equals to 12. Since this is a true statement, yes, x equals 3 is a solution to the equation x plus 9 equals to 12. Here's another example. Determine whether y equals negative 8 is a solution to the equation 3 times y plus 4 equals to 2y minus 4. In this equation, every time we see a y, we will replace that y with negative 8. So we have 3, and I'm going to use a bracket now because I'm going to replace the y, parentheses negative 8, plus 4 equals to 2 times negative 8 minus 4. Each y got replaced with the value of negative 8. Let's follow the order of operations. In the order of operations, always simplify the parentheses first. Negative 8 plus 4, that will give you negative 4, equals to 2 times negative 8 minus 4. 3 times negative 4 is negative 12. So on the left side of the equation, we have negative 12. On the right side, we have negative 16 minus 4. Now, negative 12 does not equal to negative 20, which is negative 16 minus 4. Therefore, y equals negative 8 is not a solution to the equation given. The addition principle states that for any numbers a, b, and c, a equals b is equivalent to a plus c equals to b plus c. In other words, if you add the same term to each side, the equation remains unchanged. For example, let's solve the equation x plus 9 equals to negative 13. Since the x is being added by 9, the inverse of adding 9 would be to subtract 9 from each side. Therefore, x would equal to negative 22. Let's check our answer in the original equation. If you replace x with negative 22, we will get negative 22 plus 9 equals to negative 13. If in fact x equals negative 22 is a solution, this will be a true statement. We have negative 13 equals to negative 13. Therefore, x equals negative 22 is a solution. And I forgot to use parentheses. Sorry. In the next example, let's solve the equation x minus 5 over 6 equals to negative 3 over 8. So, since the x is being subtracted by 5 over 6, the inverse operation of subtracting is going to be adding 5 over 6 to the left side and also to the right side. So we have x equals to negative 3 over 8 plus 5 over 6. Keep in mind, when we add or subtract fractions, we need to have a common denominator. A common denominator is the least common denominator is the lowest number that 8 and 6 can both go into. Since 8 and 6 can both go into 24, our least common denominator will be 24. In order to rewrite negative 3/8 using a denominator of 24, we would multiply the 8 by 3, and therefore we would multiply the 3 by 3. And that will give you negative 9 over 24. To rewrite 5 over 6 using a denominator of 24, we would multiply the 6 by 4. Therefore, you would multiply the 5 by 4 as well, and you would get 20 over 24. Negative 9 plus 20, when we have a common denominator, you can write the numerator over 24, which is a common denominator, and this will give you 11 over 24 as the answer. Let's check to make sure this is correct. Let's take 11 over 24 and replace the x value with that number. So we would get 11 over 24, which is now the x value we're testing, minus 5 over 6, and we want that to equal to negative 3 over 8. This is the original equation. Now on the left side, because we're subtracting, we need a common denominator. Between 6 and 24, the lowest common denominator will be 24, which means you would multiply the 6 by 4 and the 5 by 4. This would give us 11 over 24 minus 5 times 4, which is 20 over 24. And you want to check, does that equal to negative 3 over 8? 11 minus 20 is negative 9. You want to check, does that equal to negative 3 over 8? Well, if you reduce negative 9 over 24 by dividing each numerator and denominator by 3, we would get negative 3 over 8 equals to negative 3 over 8, which means that 11 over 24 is in fact a solution. The multiplication principle states that for any numbers a, b, and c with c not equal to 0, a equals b is equivalent to a times c equals to b times c. In other words, if you multiply both sides of an equation by the same term, the equation remains unchanged. For example, let's solve 8x equals to negative 32. Since x is being multiplied by 8, the inverse operation of multiplying is dividing, so we would divide by 8. And we would get x equals to negative 4. Let's check to see if this is correct. In the original equation, we would replace the x value with negative 4, and 8 times negative 4 does in fact equal to negative 32, so this answer is correct. Let's solve negative x over 9 equals to 5. Let me rewrite this. Negative x over 9 equals to 5. Now in this case, the x is being divided by 9. The inverse operation of dividing is multiplying. So we would multiply each side by 9. But look what happens. If you multiply just by 9, the negative sign is still there. So to change the negative sign to a positive, we would multiply each side by a negative 9. So what that does is on the left side, the 9 and 9 cross cancel. Negative times negative is a positive. On the right side, 5 times negative 9 is negative 45. So our solution is x equals to negative 45. Let's check to see if this is correct. If you replace the value of x with negative 45, you want to check, does that in fact equal to 5? Negative 45 divided by 9 is negative 5. Negative negative 5 is equal to positive 5. Therefore, negative 45 is the solution. So in this case, remember that if the x has a negative value, when you multiply by the inverse of 9, by dividing by 9 is multiplying by 9, make sure you multiply by a negative as well. Let's solve 18 equals to 2 over 3x. When the x is being multiplied by a fraction, we can undo this by multiplying by the reciprocal of the fraction, which is 3 over 2. And if you multiply one side by 3 over 2, you must multiply the other side by 3 over 2 as well. On the right side, the 2's cross cancel, the 3's cross cancel, and you're left with x. On the left side, the 2 goes into 18 9 times, and 3 times 9 is 27. So the value of x is 27. Let's check to make sure that this is correct. We're stating that 18 equals to 2/3 times our solution x, which is 27. 3 goes into 27 9 times. 2 times 9 is 18. 18 equals 18 is a true statement. Therefore, x equals 27 is in fact a valid solution. Last one, we have negative 3 over 10 equals to negative 9 over 20x. Now in this case, the x is being multiplied by negative 9 over 20. When the variable is multiplied by a fraction, we would multiply each side by the reciprocal of that fraction, which in this case would be negative 20 over 9. Notice that we have to multiply by a negative in order to change the negative to a positive. Whatever you multiply the right side by, the left side would get multiplied by the exact same term, which is negative 20 over 9. On the right side, negative times a negative is positive. The 9's cross cancel, the 20's cross cancel, and we're left with x. 20 goes into, or 10 goes into 20 2 times. 10 goes into itself once. 3 goes into itself once. 3 goes into 9 3 times. If you multiply the numerators, negative 2 times a negative 1 will give you a positive 2. Once again, we have negative 2 times a negative 1, which is a positive 2. And we have 3 times 1, which is 3. So our answer is going to be 2 over 3. And I will leave you to check this answer.